I'm Rinat Manasapov, and today I'm delighted to present my new software tool that I developed for sizing HVAC infrastructures of non-residential buildings. First of all, let me define the term HVAC infrastructure. In the context of this overview, it means a suite of heating, ventilation, and air conditioning equipment connected together in an integrated system by ductwork and piping. And the ductwork and piping is an indispensable part of the HVAC infrastructure. So the new tool is capable to size virtually all elements of the HVAC infrastructure. For 2 decades, I used quite a few software tools for the HVAC design and energy analysis. However, I have never been quite happy with the tools for a few reasons, and the main reason is the tools do not allow for sharing input and output data with other computational procedures or tools. They don't allow to customize the tool with your own calculations that you might need in the course of your design. In the past, I worked in the R&D area and developed quite a few sophisticated algorithms for software tools commissioned by third parties. So eventually I decided to develop my own tool, the tool that I really like. The key feature of the tool is the Microsoft Excel platform that I used to develop the tool. Essentially, the tool represents a spreadsheet with a set of formatted tabs for data input and output, a VBA code that runs behind the scenes, so to say, and a user's control panel that allows you to trigger selected computational procedures. As any other spreadsheet, you can replicate it as many times as you like. You can link it with other Excel files or procedures. You can expand it with the new calculations you like. None of existing tools provide such a huge flexibility. I should also define the term sizing. It means prediction of the heating, ventilation, cooling, and other performance characteristics for all infrastructure components. For example, sizing of the cooling coil in an air handling unit means defining the sensible latent total cooling load of the coil, the airflow requirements through the coil, the moist air properties on both sides of the coil, and other characteristics that would be required to determine the physical size, model, and characteristics of the coil in question. The HVAC sizing process is a series of streamlined computations where the output from one computation procedure is the input for the other. With the existing tools, the process of transferring data from one tool to another is manual, and it creates the risk of potential typos and consumes substantial time. Thanks to the standard Microsoft Excel features, the data sharing, upgrades, changes, comparative analysis, etc. are quick, accurate, and easy. As I mentioned before, the output of the tool is the set of performance requirements for all HVAC components that allow for selection of the model and physical characteristics of each HVAC component. Let me show you a slide that demonstrates the range of HVAC components that one tool, and let me call it a module, can size. Here we are. The building or function area can consist of 100 spaces, 5 air handling units, 1 heating plant, and 1 chilled water plant. The individual HVAC components that can be sized are all hydronic heating and cooling units, such as baseboards, induction units, fan coils, etc. All air terminals that could be reheat coils as shown in this schematic, variable air volume boxes, fan powered boxes, all the air handling unit components, the supply fan, the cooling coil, humidifier, heating coil, and of course the return fan. All the primary energy systems, the heating boiler, the associated heating, hot water or glycol or any other fluid, piping, the associated heating pumps, the chiller, the chilled water piping and associated chilled water pumps, primary and secondary. And of course, an important component of the HVAC infrastructure is ductwork. So the supply air ductwork and return air ductwork can also be sized by one module. Perhaps you want to ask a question, what if the number of spaces exceeds 100? What if the number of air handling units is greater than 5? Or you have a campus with many buildings and function areas? Well, in this case, the tools, the modules, can be seamlessly combined together into a single integrated computing system. A few words on the thermal load simulation and duct sizing methods. In this tool, I use the radiant and conduction time series method to simulate thermal loads, which is highly recommended by ASHRAE for sizing non-residential buildings. To calculate the friction losses in the ductwork and piping, I used a recently developed derivative of the Bernoulli equation. It's called Churchill equation. Again, it was highly recommended by ASHRAE to size any fluid conduits. And this is an alternative to the common Colebrook equation that requires a table or a chart. To summarize my hopefully eloquent enough speech, I would like to say that consulting companies and professionals providing HVAC design services can benefit from using the tool by reducing the cycle and cost of the HVAC design process, by reducing the human errors margin, by increasing sizing accuracy, and improving experience of the engineering staff. Thank you for watching this video, and I hope to see you at my next tutorial where I will show you how the tool works. For more details, or if you want to download demo version of the tool, please visit my website, which is www.hvac-academy.com.